Greetings to you, members of this classroom. I really appreciate for joining me at this point in time. Okay, with me here is the question that I want to run you through so that you can grasp the concept on how you can answer examination-oriented question. And this is a question which is coming from Science Paper 2 under a topic called chemical bonding. Quickly, let us go through the question and see how we can handle this particular question in an amicable way. Okay, question 1A. Draw electron shell diagram to show the ionic bonding in 1, magnesium oxide, 2 marks. Then bullet 2, lithium fluoride, 2 marks. Then B, explain why metals are good conductors of electricity. Then 2, ionic compounds have high melting and boiling points. Okay, so these are the questions that we have. So now let us see how we can answer this question that is on the body. Solution. Okay, so now here we have magnesium oxide, which is a compound. Okay, so now how we can write the electron shell diagram to show magnesium oxide. First of all, we are going to identify the magnesium on the periodic table. Okay, so the chemical formula for magnesium is the Mg. Okay, so when you go direct to periodic table, you will find that this is the formula for magnesium. Then magnesium has got 24 mass number and 12 atomic numbers or number of protons. That is magnesium. Then when we come to oxygen, the chemical formula for oxygen is just O. Then oxygen has got the mass number of 16 and the atomic number of 8. Yes, so now when you look at these two elements, they are all found on the periodic table. But this one is the metal and oxygen is a non-metal. No wonder why when these two bonds, okay, come together or react, they make a compound known as ionic compound. Okay, because here it involves actually the transfer of electrons. Yes, so now let us see how we can write the electron shell diagram. So we are going to start with the magnesium. So when writing the electronic shell diagram, we always consider the atomic number, okay, or the proton numbers. So let us start. So the first shell always contains how many electrons in its outermost shell is what? 2. So the first one contains 2 electrons. Okay. Then the second one should have 8 electrons for it to be stable. Okay, now when you look at the atomic number that we have here, we have 12. So when we subtract 12, because 2 are already stationed in the first shell, then here we have remained with how many electrons? 10. So it means we have remained with the 10 electrons. So out of that 10 electrons, we are going to get 8 electrons that we are going to put on this outermost shell so that it can become stable or balanced. So we are going to put electrons here, 2, here 2, here 2, the other side 2, even here 2. Okay, so this is now 8. 1, 2, 3, 4, 5, 6, 7, 8. That is how the electrons are being lined in those shells. So now from there, remember, we have just used 10 electrons out of 12 electrons that we have on magnesium. Okay, so now that means we have remained with the 2 electrons in the outermost shell. Now, when it reacts with the oxygen, which is the non-metal, let us also write it here. Oxygen, always the first shell should contain how many electrons? 2 electrons. Then we come to the last shell. The last shell. So here we need to indicate even the curl bracket there. We indicate. Then on lithium, on oxygen, I mean, oxygen, we have how many atomic numbers? There we have 8 electrons. So these 8 electrons now we are going to actually subtract 2. So when we subtract 2, we remain with how many? We are going to remain with the 6 electrons. So this one, in the second shell, we are going to have 6 electrons. Okay, now it means this element is not stable. Why? Because it still needs 2 electrons for it to be stable. So now that it is reacting with the magnesium, which has got 2 electrons in its outermost shell, we are going now to transfer those electrons, because on the ionic bond, this is a situation where electrons are being transferred from the metal element to a non-metal. So here we have 2. So that those 2 elements which were left in the last outermost shell is going to be transferred. So it means here we are going to indicate a 2+, showing that, or rather indicating that, this element has transferred 2 electrons to oxygen. Okay? So now those 2 electrons will be here to make it 8 electrons. And to show that oxygen has received 2 electrons from the magnesium, we are going to indicate a 2, then we say minus there. It means this element has gained electrons, or 2 electrons from the magnesium. Magnesium has lost 2 electrons. Hence, the electron shell is drawn. That is how we draw the electron shell. Okay, so this is 2 marks. This is 2 marks. So it means we have scored those 2 marks. Then quickly we go to the next question, which is lithium fluoride. Lithium fluoride. So for lithium fluoride, remember, again, this one has got how many electrons? I mean, this one has got 2 marks also. Yes. So now, let us identify these elements on the periodic table. So lithium has got 3 atomic number and 7 mass number. Wow, fluoride has got 19 mass number and 9 atomic number. So let us indicate that one, like what we did on the first question. So we are going to say lithium. This is the chemical formula for lithium, 7. Then we have 3. Then here we are going to write fluoride or fluorine. This is fluorine. Fluorine has got 19 mass number, then 9 electrons. So these are the chemical formulas of those elements that reacted to come up with that compound. So now, having identified them in chemical formula, it is very easy for us now that we can actually show on the electron shell diagram. Okay, so how? Like what we did there, we are going to start. Always the first shell contains how many electrons? First shell contains 2. So now that we have 3 electrons there, so it means we have just remained with 1 electron. So before we proceed here, the question here comes, which one is the metal there and the one which is a non-metal? Fluorine is a non-metal. This one is found in the first group. Okay, no wonder why it is having 1 electron in its outermost shell. That one simply means it is in the first group. Then this one is a non-metal. So again, the bonding which is taking place there is same as the one which was between magnesium and the oxygen, which is ionic bond. That's why even in the question they said draw electron shell diagram to show the ionic bonding in it. So here we have the one who is the lithium is the metal, then fluorine is the non-metal. Okay, so it also involves the transfer of what? Electrons. So this one, since 2 we have already put there, so it means we have remained with 1, which is supposed to be in the outermost shell. So that one will be transferred to a non-metal, which is fluorine. So here now it will be first for non-metal we have 2. We have 2 electrons. Then second, remember when we subtract 2 from 9, we are going to remain with 7. So in the outermost shell, we are going to have 7 electrons. 7 electrons. This is 6, so here we put 1. Plus 1, which has been transferred from lithium, which will give us 8. And this compound will become what? Stable. Okay, so now to indicate that lithium was losing 1 electron, we are going to put positive here, negative. So it means lithium fluorine has gained 1 electron, then this one has transferred 1 electrons. Hence the diagram drawn. That is how we answer these questions. Simple and straightforward. So having done this, it means you have scored 4 marks, which is very, very important. So I should also indicate here 2 marks. Then we come to question B. Okay, so question B says, explain why metals are good conductors of electricity. Why metals are good conductors of electricity? The reason why metals are good conductors of electricity is because ionic bonds has got the strong electrostatic force of attraction between ions. Hence, breaking such compound requires great energy, which is the high temperature. Okay, so let me write that point. So I think for B, I'll write here B1. So the reason why metals are good conductors of electricity is because metals, let me write it properly. Okay, for question 1, this is 1. B1. So metals, we are on metals. Why they are good conductors of electricity? Because metals as free mobile electrons that enables them to conduct electricity. Then for 2, I'll come back to explain, or rather to say something on that. We come now to ionic compounds. Why ionic compounds have high melting and boiling points? Because ionic compounds have the strong electrostatic force between ions. Hence, to breaking such compounds, requires, let me use this other part of the body, requires great energy. It is high temperature. Okay, so these are some of the reasons why metals are good conductors of electricity. Metals has got free mobile electrons that enables them to conduct electricity. So the electrons that are found in metals, they are free. They are free movement. They move, okay, from one place to another. Therefore, because of that, they are able to do what? To conduct electricity. That is the reason why metals are good conductors of electricity. Then 2, because ionic compounds have the strong electrostatic force between ions. Hence, breaking such compounds requires great energy, high temperature. So the reason why ionic compound has got high boiling and melting temperature or points, it's because they have the force that is in between them, okay? The electrostatic force is very strong, okay? It's so strong that it requires a great energy for it to be broken. It means there should be high temperature, high boiling point, and high melting point for it to be broken. Okay, so that is the reason why electrons, ionic bonds, have got the high temperature and boiling points. Thank you so very much. So this is how we handle questions that comes under chemical bond. Thank you for your attention. See you next time.